last time we saw application of heating of electric circuit while using the electrical appliances. This time we will see same principle, heating effect of electric current. One more component is called fuse. This fuse is connected to each and every electrical appliances, and also in our main switchboard a white color ceramic fuse is there. For what reason this fuse is required and what is meant by fuse, today we will see. Fuse is nothing but it is a device used in an electrical circuit, and it is a safety device. So fuse is a safety device. Safety means what? It protects. For protecting electrical devices, in our house we have so many electrical devices, and all these electrical devices should be protected from the electrical short circuits or overloads. For that we need the fuse. So it is a device used in an electrical circuit for protecting electrical devices against overloads and short circuit. See, I told you, overloads and short circuit. We need the appliances and all the wirings in our home to be protected from overloads and short circuit. For that reason, we need fuse. So, it is a safety device. It works on principle of heating effect of electric current. So, it works on a principle of heating effect of electric current. Two words I have used over here, overload and short circuit. You may not be knowing what is meant by overload and what is meant by short circuit. That I will explain you now. Overload. Overload means what? Too much current passes through electric wires due to overuse of extension cords and multiple plug adapters. Means what? You have multiple plug where on the same switchboard many plugs are there, and at a time you are using the plug for mixer grinder, the same plug for washing machine, same plug for dishwasher, like this way. At a time you are using all those plugs together. They are called multiple plug adapters, or extension cord wires where also multiple plugs are there. You are using all the electrical devices at a time. That time what may happen? The demand of the current will become too much. The current will flow too much, where the circuit is unable to tolerate that excess of current, and that time it makes the wire to heat and melt, causing fire. That is called overloads. At that time this fuse will help. It will break and it will create a open circuit where the current cannot pass. So our wires and devices will remain safe. That is, it is called as safety device. When such overloads occur, that time this fuse will protect our appliances. Second one I told, short circuit. What is meant by short circuit? It is a situation, always it won't occur. It is a situation in which live wire touches neutral wire. What is live wire and neutral wire? Ma'am, we don't know what it is. We know that the electric current is produced. Okay? And we are getting this electric current from the nearby pole in the street. Now in our street, poles are there. From that poles, the electric wires are drawn. Two wires will be there. One is a live wire and another is a neutral wire. What is meant by live wire? It is a wire in which the current is flowing. What is neutral wire? It is also a wire which helps to complete the circuit. So it is a conductor which helps to complete the circuit. It is called as neutral wire. So what may happen, sometimes this live wire comes in contact with neutral wire, or fault in insulation. Okay, in your house, when a wiring is taking place in your house, or you are using the electrical appliances, you will see that insulation is there. Outer part of the wire is covered with rubber insulation. Why? Because when current is passing, when we touch the wire, we may have shock. So to prevent that electric shock, this insulation is required. Sometimes we may not pay attention to our electrical appliances. Old electrical appliances will be there. The insulation may have gone from the wiring, and when such situations are there, in that situation the live wire and neutral wire will come in contact with each other. Due to that, what happens? The resistance becomes less. The resistance is less, the current will increase. So there is will increase in the volume of current at a time, which will immediately flow to the circuit, causing fire or explosion, and that will be avoided by the fuse. It will safeguard. That is why fuse is a safety device. I told you regarding the live wire, neutral wire and earthing wire. Overload and short circuit occurs due to live wire and neutral wire. What is meant by live wire? A wire in which the current is passing. It is called as live wire. What is meant by neutral wire? Circuit conductor which completes the circuit back to the source. If in your main switchboard, this neutral wire and live wire both will be taken from the pole, the neutral wire will be drawn through each of your rooms, and it is again coming back to the main switchboard. So it completes the circuit. If circuit is not completed, the current won't flow. So to complete the circuit, neutral wire is required. Earthing wire. It is the third wire which is not coming from the pole. It is taken from the house only. Before you construct a house, for earthing, the earth is dug for a certain feet down, and on that coal, salt and a copper wire is drawn out of it, and that is called as the earthing wire. For what reason? If any high voltage current having large volume of current flows through the circuit from the wire which is connected to the poles, immediately this earthing wire will send that extra amount of current to the earth. It won't allow to flow to the circuit. So it is a earthing wire is like a safety measures for electric circuit and appliances. So on the whole, in any house, from the main switchboard, 3 wires are drawn out: live wire, neutral wire and earthing wire. Next we will see what are the properties of fuse. So fuse is a safety device, I told you. Then what is fuse made up of? It is an alloy, combination of 2 elements, combination of element and non-element, we call it as an alloy. So it is an alloy made up of 75% of lead and 25% of tin. Together that is what the fuse is made up of. It is placed in series with devices in circuit. Whenever the fuse is connected in the circuit, it should be always connected in series, because the flow of current should be constant. That is why. Symbol of fuse used in circuit is, this is the symbol used. And very important property it is having that it has high resistance and low melting point. The melting point should be very low, because if any extra amount of electric charges or current flows, this fuse wire should melt, and what will happen? It will break the circuit and it will stop the damage of electrical wires in our house and electrical appliances. That is how the fuse works. So its melting point should be low. That is why it is an alloy which is made up of 75% lead and 25% tin. The resistance should be high, but the melting point should be low. This is what the properties of fuse. Now let us see what are the advantages of fuse and disadvantages of fuse. First, let us see what is advantages of fuse. Fuse is the cheapest form of safety device. So very cheaply, with a proper rating, fuse should be used. And whenever you are using a fuse, it should be consulted to the electrician, because they may be knowing what is the proper rating. So, cheapest form of safety device. Requires no maintenance. It does not require any maintenance. It's whatever the weather changes is there, whatever the circumstances it has to face, it does not require any maintenance. Can break heavy short circuit current without noise or smoke if your device is not having fuse. So, if the current increase and the volume of current flows, large volume of current flows through your appliances or circuit, what may happen? The explosion sound will come and smoke will be coming out. But if fuse is there, it won't allow that noise or smoke to come. It won't allow the wire to burn. Instead, it will break the circuit and protect the appliances and wiring. That is why it can break any heavy short circuit current without noise or smoke. Third one, operation is automatic by itself. A small amount, it is said that 15 to 20 amperes of current is required for the household purpose. So if the ampere is more, immediately the fuse will start its work by melting and making the circuit to be opened. So, its operation is automatic. A small high amount of current enters into the electrical appliances. Immediately the fuse will start working. It breaks the circuit and it protects that particular appliance and the wiring in the house. So its operation is automatic. It does not require anyone's permission, or you should switch on or switch off. It works by itself. So it is automatic. Now let us see the disadvantages of fuse. Suppose the fuse in your house, due to the high voltage or high amount of current has entered and the fuse has gone. So you have to replace that fuse. It takes considerable time. You can't do by yourself. You don't become an electrician. You have to take the advice of electrician, or you have to call KEB person and have that fuse replaced. You cannot do the replacing of the fuse. So it takes considerable time to replace the fuse. And copper can also be used as fuse. Aluminum can also be used as fuse. And silver can also be used as fuse. So, but copper, aluminum, silver alone using fuse is very dangerous because they don't have high resistance. It may damage the electrical appliances and it may damage the wiring. So, if you have knowledge that by connecting copper wire we can replace the fuse, don't do that. You should call KEB person. That person will bring a proper rating of fuse and that has to be connected properly. Second disadvantage, on heavy short circuit, the discrimination between fuse in series cannot be obtained. Sometimes what may happen, due to heavy amount of or large amount of current entering into the circuit, so the current, that is the fuse, may not be able to will not be able to recognize that high amount of voltage and it may not work and it may allow that voltage to enter into electrical appliances, which may cause a damage. So sometimes that disadvantage is there in the fuse. Current time characteristics of fuse cannot be always correlated with that of the protected appliances. Means each appliances have its what you call it as power and rating. So sometimes the current time, we cannot say that this appliance is for this much time when high voltage or high amount of current it is exposed, it will be damaged or fuse may not work. So current time characteristics of fuse is not correlated with the protected appliances. So how much time the current should pass through the appliances? Okay, if a high voltage or high amount of current passes, the fuse may not be able to recognize that. The current timing, it may not be able to cut down that current time characteristics to enter into the appliances, which may cause the damage damage to the appliances. That is the main disadvantage of this fuse. So what should be done if that much disadvantages of fuse are there? In the main electrical supply board, this fuse will be there. But nowadays, new types of fuses are there. MCB is a miniature circuit breaker. It is called MCB. Miniature circuit breaker. Nowadays, this particular fuse is used. It is also a type of fuse. In your houses, this may be there. A green color switch type of device is there. If the excess amount of current enters, that switch automatically comes down till that excess current is removed from the circuit. Again this will automatically switch on and the circuit will again become closed. So miniature circuit breaker. This is the new, what we call it as device, which is also a safety device. Instead of using fuse, this is nowadays is used miniature circuit breaker, MCB. When we are using fuse, rating of fuse is very important when we are connecting fuse in our household. In our household, there will be two separate circuits. One is a 5 ampere fuse circuit, which is called lighting circuit. In that, under this 5, what is meant by 5 ampere fuse lighting circuit means? All these devices will use within 5 or less than 5 ampere current. And these, they are connected with such wires, and that is a separate circuit, we call it as lighting circuit. So, if in a lighting circuit, any fuse is gone, only that circuit will become open. But the other, which is called heating circuit, will run as it is. So, that is why it is separated as lighting circuit and heating circuit. Let us see some examples where which devices use electric current within 5 ampere. Clock radio uses 3 ampere of current. DVD player uses 3 ampere of current. Coffee maker uses 5 ampere of current. Your LED bulbs, your fluorescent bulbs use 3 ampere of current. So all these devices come under lighting circuit. So they are connected with 5 ampere fuse. Next is 15 ampere fuse, which is called heating circuit. Okay. Why lighting circuit means your LED bulbs, they provide light. So that is this lighting circuit, and less amount of current is required for these appliances to work. So they are called as lighting circuit. 15 ampere of fuse heating circuit, where heat is required for that particular device. So heating circuit, it's a heavy, what we call it as voltage appliances, where more current is used. It is separated out because in 5 ampere fuse, heating circuit cannot be connected. Immediately if you connect it, there will be a short circuit. So the chances of appliances to be burned or fire or explosion to be taken. So 15 ampere should be connected with lighting circuit only. For 5 ampere should be connected with lighting circuit, and 15 ampere should be connected with heating circuit only. Let us see the examples. Dishwasher, 13 ampere is required. Washing machine, there also 13 ampere is required for washing machine. You know that what is a washing machine? It washes the clothes. There also, when the cylinder which is inside the washing machine rotates, due to the high speed of rotation, whatever the dirt is there in the cloths can be removed out, and that is washing machine also requires 13 ampere of current. Toaster, heating effect is needed, it requires 13 ampere. Oven, heating is needed, it also requires 13 ampere. Iron box, heating is needed, it also requires 13 ampere. So wherever heating is required, it is those devices or those appliances which requires more amount of heat, they are connected with 15 ampere fuse, which is called as heating circuit. Thus, in our house, there are two separate circuits, 5 ampere fuse lighting circuit and 15 ampere fuse heating circuit. Now let us try to see the next topic, which is called electric power. What is meant by electric power? Rate at which electric energy is dissipated. Dissipated means consumed. How much electrical energy is consumed by a particular electrical appliance. It is called as power. All the appliances have different powers depending upon its electrical energy consumption. We call it as electric power. In any electric circuit, how many electrical appliances are connected? Each electrical appliances have different rate of consumption of energy. That is electrical energy, and that rate of consumption of electrical energy is called as electric power. It is denoted by symbol P. So electrical power means how much electrical energy consumption. What is electrical consumption means? In each electrical appliances, I told you, potential difference is there, and in each electrical appliances, current is flowing. So the product of potential difference of that particular electrical appliance and the amount of current flowing through that particular electrical appliances is called as power. So power is nothing but it is the product of potential difference and current V into I. So V potential difference, its SI unit is volt. Electric current, its SI unit is ampere. So the SI unit of power is volt into ampere, which is called as watt. So the SI unit of power is watt. Formula to find power is V into I. So what is the meaning of 1 watt? 1 watt means what? 1 ampere of current is used in that particular electrical appliances. To obtain a potential difference, 1 volt is called as 1 ampere. Watt is a unit used for smaller amount of power. There are other units for power also. Higher amount of power is measured in higher units. That is kilowatt, megawatt, gigawatt and horsepower. What is 1 kilowatt? 1 kilowatt is equal to 1000 watt, or in exponential form 10 to the power of 3 watt. 1 megawatt is equal to 10 to the power of 6 watt. 1 gigawatt is equal to 10 to the power of 9 watt. 1 horsepower is equal to 735 watt. Horsepower is used for only the watt pump, where the water pumps are used for that, only the horsepower is used. What is the unit now? I told you the electrical energy used. So the unit of electrical energy is denoted by E. How to calculate how much electrical energy is used by that particular device? So it is 1 watt per hour. If 1 watt power is flowing through the electrical appliances, in 1 hour it uses 1 watt of power. It means the electrical energy used is 1 watt per hour. But that is for the calculation purpose. But commercial unit, what do you mean by commercial unit? We are not getting electricity free. We have to pay every month electrical bill to the KEB. KEB is giving us the electricity. So to pay electric current bill to KEB, we have the electrical energy is converted into commercial unit. What is a commercial unit? Commercial unit is 1 kilowatt per hour, which is it is also called as 1 unit. That means how many appliances are there in our house, how many hours we are using that appliances, total number of these appliances used how many hours is added and calculated, converted into kilowatt per hour. 1 kilowatt per hour is 1 unit. Suppose in that particular month the total amount of current used or the electrical energy used is 3 kilowatt per hour, means the commercial unit says 3 units is used, and the KEB has specified or given rating for 1 unit, some amount is fixed. Calculating that amount, your electric bill is every month coming to you. So this electrical energy is very important. So we can say unit of electrical energy is 1 watt per hour, but commercial unit is 1 kilowatt per hour, which is calculated for electric billing is 1 unit. 1 kilowatt per hour is 1 unit. So this is regarding the electric power. Let us see now sums based on electric power. Let us see the first sum. Let us see what is given. An electric bulb. So here electric bulb is taken. Is connected because circuit should be there. So it should be connected. So an electrical bulb is connected to a generator. So an electric bulb is connected to a generator of 220 volt. So the voltage in that generator is 220. The current flowing through the electric bulb is 0.50 ampere. You have to calculate what is the power, of the bulb. So let us try to understand what does this sum say. So here let us again read the sum. An electric bulb. So an electric bulb is there. It is connected in a circuit with a generator whose voltage is 220 volts. The current passing through that bulb is 0.50 ampere. So how much is the power of the bulb? So let us calculate. So solution. So first we have to write down what is given. Is the voltage given? Is the potential difference given? Yes. V is equal to 220 volts. Is the amount of current flowing given? Yes. It is given how much? 0.50 ampere. So I is equal to 0.50 ampere. What you have to find out? Power. Power is how much? Let us take the formula. Already in the previous I showed you how to calculate power. Power is nothing but it is a product of potential difference and current. What is potential difference? V. What is current? I. So power is equal to V into I. So that is equal to 220 into 0.50. Okay. Now let us multiply. So easiest way of multiplying is, how many zeros are there? 2 zeros are there. So first you keep the 2 zeros. Now take 5 and multiply with 22. That is 5 2s are 10. Carry 1. Again 5 2s are 10. 10 plus 1 is 11. How many place of decimal point you have to keep? 2 place. 1 2. So this is so power is 110 watt is the power of that particular bulb. So an electric bulb whose potential difference is 220 volt and current flowing is 0.50 ampere, then the power of that particular bulb is 110 watt. So came to know how to solve this sum. Let us see the second sum given in this. What is given in the second sum? Electric refrigerator. All in your houses you may be having the refrigerator. So electric refrigerator, okay, is taken. Its power is given. It is rated 400 watt. Means the power of that refrigerator is 400. Okay. And it operates. Whole day the refrigerator should be operating. It is operating 8 hours per day. In one day, 8 hours it is operating. What is the cost of energy? What is the cost of energy to operate? Okay, it for 30 days. How many days? 30 days at rupees 3 per kilowatt hour. So let us see what is given or what you have to do in this particular sum. So electric refrigerator rated 400 watts operates 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt per hour? That means the power of the refrigerator is given. So solution. So what is given? P is equal to 400 watt. Okay. Then time is given. How much time? 8 hours, and that to how many days? 1 day. You are going to work this refrigerator for how many days? 30 days. So in 1 day it takes 8 hours it is working. So in 30 days how many total hours we have to find it out. So total hours in 30 days is equal to 8 into 30. So how much it is? 240 hours. Okay, 8 hours 1 day. So 30 days how many hours? 240 hours a day. Now we have to find out the cost. So first we have to find out how much is the total power. If one refrigerator is working 8 hours per day, so in 30 days how much is the total power? So power will be equal to, so you have to find out how much is the electrical energy consumed in 30 days. That is E. What is E is equal to? So electrical energy consumed is equal to power into time. How much is power given? Power is 400. How much is time given? 240. See, total time taken is 240. And how much is the power given? 400 watt. So we have to multiply. I'll show you the same method, easy method. How many zeros are there? 1, 2, 3. So 1, 2, 3. Now take 4 and multiply with 24. 4 4s are 16. Carry 1. 4 2s are 8. 8 plus 1, 9. So you got 96,000 kilowatt hour. That is total energy used by one refrigerator whose rate is 40 watt and how many days? 30 days. Now we have to find out how much amount is to be paid for this. Cost is given. How much is given? 3 rupees per kilowatt hour. So for 1 kilowatt hour, 3 rupees. Then for 96,000 kilowatt hour, how many rupees? So that I will show you the calculation over here. That means, let us see now further the calculation. So we got the total electrical energy. So we have to find out cost. So cost is equal to total electrical energy into rate of energy. So what is total electrical energy? 96,000. So 96,000 into how much is the rate? 3 rupees. So is equal to 3 zeros are 0, 3 zeros are 0, 3 zeros are 0, 3 6 are 18, carry 1, 3 9s are 27 and 128. So this much is the amount to be paid.